Feel free to start.
Sure. Hi, everyone. Good morning, good evening. Thanks for joining. Today, we are going to talk about what's new in Avi 31.1, which we did the collaboration with Intel for enhancing the scale and performance for the SSL transactions. Today, we are joined by our Intel speakers as well. I'll let them introduce themselves quickly. Saidlu, do you want to go first?
Yeah, sure, Aziz. Thank you. I'm Saidlu Aldas. I'm working at Intel as a principal engineer. I'm part of a data center and AI group inside Intel. My majority of work goes in networking side, innovation, pathfinding, and working with VMware and accelerating VMware stock with IA Intel architecture. Thank you. Kannan, you want to go ahead?
Yeah, sure. Thank you, Saidlu and Aziz. I'm Kenan Mani. I'm a global technologist here in Intel as well. Most of my focus area is to work jointly with VMware for a joint roadmap, enabling vSphere on top of Xeon platforms. I also work on our AI accelerators as well, and also focus more onto the edge and telcos kind of the world, especially on the networking side. That's what we're going to talk about here. So happy to join this panel and discuss more. So back to you, Aziz.
Thank you. So thanks a lot, Saidlu, Kanan. And a quick introduction about me. I am Aziz. I am a technical product manager for Avi Load Balancer. And I focus on performance, scale, and network protocols, as well as the VCF integration. Kanan and Saidlu were really critical for the whole collaboration, and we'll discuss in a bit more in detail on what are the technology aspects which made this collaboration work together. Quickly, the agenda for today's webinar is we'll discuss about what are the trends and needs required for delivering modern applications. How does Avi navigate these trends? And we are going to uncover what we have done in the latest 31.1 release, which got GA'd on 31st January. It is available for customers to deploy and try it out. And as part of this, because we needed the scale improvements, we utilize Intel QAT. We'll do a deep dive on it, what it provides. Saidlu and Kanan will showcase the capabilities, what Intel has on the QuickAssist technology, and how Avi is utilizing this. I'll cover the benchmarks and demo, and then we'll go through the resources, references, and the Q&A session. So please feel free to send out your questions in the Q&A panel chat. We'll have ample time to answer these questions towards the end of the session. So let me get started with what are the market trends and challenges for today's modern applications, right? The first factor is basically the infrastructure as cloud being the trend, where everybody wants the cloud first kind of architecture for all their applications, from deploying to managing and to scale those applications. Also, one of the critical requirements is security. Nowadays, there have been a lot of ransomware attacks. Every day you hear millions of users or data being hacked and leaked. So it is becoming very critical to have security as a first to design the applications or to kind of provide the services to make them available. And we are living in the application economy. Everything starts and ends with an app on the phone or a web application. So all services and technologies are kind of driven by application economy. Since the cloud adoption and even the data center, the trends has been more and more evolving towards application economy. So applications have to scale and address from day zero. Earlier, it used to be like you deploy some application, then you had enough time to kind of scale it when it goes in production. But now it has to be ready on day 0 for monetization, right? And we are also seeing a lot of influx of AI and Gen AI assistants, and a lot of capabilities kind of being done or provided by applications or LLMs, which are kind of getting built into those applications. So for these trends, what are the guiding principles? What are the things a application developer or application owner needs to have as guiding principles to address any of these trends, right? To have the cloud infrastructure as service cloud, they need to have a cloud operating model, which should be software defined. It should be self-service and scale out built in, right? It cannot be that you have deployed a cloud which requires weeks and days to kind of prepare the environment or deploy the applications. Typically, what we hear from our customers is that when in the past, they used to take around 30 to 40 days to kind of, even when the solution or app is ready to get it to production, the way they need to interact with their IT teams to get the app live with respect to requiring the DNS configurations, the IPAM requirements, the underlying infrastructure requirements. So that has kind of getting collapsed more and more with public clouds and the private cloud being operated in a cloud operating model. It has kind of come down to weeks now, and quite a lot of hyperscalers try to do it in day-to-day activities, right? And on the security, you need, it's not just, applying some firewall or applying a point solution of security. You need to have visibility on what is happening to detect and mitigate those attacks. You need to have a threat defense, end-to-end threat defense from lower end of the stack to the higher end of the stack. And as well as for the application scale, you require visibility on the health score, latencies, and the performance metrics, right? On the Gen AI, how they are helping is with the influx of so much data. They help with triaging, explaining, recommending, and encompassing all the intelligence in a simpler chatbot or an interactive manner, right? So now what are we doing at Avi to address this? We are driving all these innovations, and the scale and performance is the most critical thing for all of this. So Avi provides or solves this, addresses market trends with this guiding principles. We follow a software-defined networking model for our load balancing solution. We have WAF and DDoS protections and DNS protections inbuilt into the product. We provide very high, rich visibility and analytics for your load balancing applications. And we are evolving our platform to adopt. We used to have AI ML kind of predictive AI already, but now we are adopting generative AI to make it a lot more easier for our customers to adopt and use our functions. So having said that, what are the challenges to scale the applications, right? If you kind of try to drill down to what exactly are the problems which are load balancing admins or virtualization admins look at, is basically the performance factors, which include the CPU and throughputs. Just to solve the scale, generally the easiest approach is to give more and more CPU or more and more throughput, right? But that can solve not efficient. It is very high cost. You will have to manage multiple load balancers, and you need to do a lot of pinning when you have a lot of disparate load balancing and pairs. You will have to do pinning of traffic or segmentation of traffic kind of scenarios. This creates a lot of operational overhead and underutilization of resources, right? And which is very effective. So having said that, how does Avi address these things? So legacy load balancers generally have box by box config, which means in the same appliance, they have the management control plane and data plane. What it means is that it's a box by box. If you have to upgrade the box as a whole. And if you have to configure, you have to go to that management plane in that box to configure them. And to manage, if there is somebody saying that, hey, my traffic is having some issues, you have to go to that explicit load balancer, which is handling the traffic and try to troubleshoot, right? Whereas what Avi is taking the approach is of separating the control plane and data plane, which is the software-defined networking principle, so that all your configurations come from the centralized management plane and control plane, and those get pushed to the data plane wherever it needs to be realized, right? So it auto detects and creates the data plane, and the configurations are also pushed based on the capabilities, right? If you have a data plane which is having the QAT capability, we'll be able to enhance those performance requirements there. If that environment has some GPU capabilities and all, we'll be able to deliver such capabilities. And that's the solution what we are trying to solve with Avi Load Balancer. So that was a quick introduction for somebody who was new to what is Avi and how Avi functions. So the control plane is called as controller clusters. It's a 3-node controller cluster deployment, and the data path elements are called as service engines. This is where the actual packet load balancing happens in the data path. This simplifies the operational complexities of managing multiple load balancing box by box configurations. Everything can be now centralized and managed from one controller cluster, right? And Avi can scale to 500 service engines with 31.1 release, which massively reduces your managed devices to more than 20x. Right? So summarizing, Avi provides all application delivery functions like server load balancing, which is local load balancing, global load balancing, which is GSLB or GTM functionalities, and DNS included in it. And it's the same solution which will work for Kubernetes, and it has inbuilt WAF, web application firewall, and it has rich analytics which we can explore and troubleshoot your environments. What does it mean? It gets deployed by quite a lot of our large customers. They have 40,000 VMs, 17,000 VIPs running on those environments, 9,000 global services, and WAF enabled on more than 2,500 virtual services. And this is single environments of our customers. And so there was a study done by a third party for our the customers who use Avi as load balancers, compared to what they were doing in the legacy load balancers. They were able to deploy 90% faster. They were able to reduce the TCO by 43%, and they got higher productivity for their application teams, their DevOps and developer teams, by 27%. And explicitly, when they did comparison with F5, they were seeing a cost benefit using Avi of about 40%. In some cases, we saw more than that. The larger the environments, the better the savings customers have. So having said, given the introduction, I want to kind of let the Intel team kind of talk about what QAT does that and how it solves the performance and scale issues what our application load balancers need. Karan, Saidlu, you want to go?
Yeah, this is great. Thank you, Aziz, for setting the stage. So as you probably, just to recap, you all heard about the challenges, both business as well as the technical challenges. You heard about what Avi can do, but let's also hear about from Intel what we can add value on top of it, right? So today we all see like, oh, well, we are all getting chips, but not the chips you're going to get. The chips are going to be more smarter. We call smart chips nowadays, right? So that's what Intel Xeon is capable of. So Intel Xeon has an inbuilt accelerator, which I think we will talk about in the next slide, But look at the way it's all those inbuilt accelerators is going to do the performance and efficiency. All you're trying to do is based on the workload, whether it's going to be an enterprise level workload, networking kind of a workload, or load balancing or security, you're trying to offload it into the inbuilt accelerator. That's what we call it, like smartness and smart chips. It's already in the chip. You don't have to pay anything on that, no licensing fee, nothing on it. All you're trying to do is offloading that into the accelerator, which is built in, and then your CPU cycle will goes down. All the work will be done on the accelerator. So if you look at it, all those four kind of pillars here, like AI, deep learning, data analytics, networking, and storage, those are all key things, right? So I think we enable across, we have accelerator for all each of these pillars, but today's topic is mostly on the networking. So we'll talk about that really, going forward, okay? So next slide, please. Thank you, Aziz. Okay, so this is one of those overall value that Intel Xeon provides for our enterprise customers. I kind of showed earlier, like you saw all those four buckets, right, with all those the categories which has been focusing on where Intel drives the much of the efficiency. If you look at AI, if you're doing recommended systems or NLP, image recognition or object detection, these are the key things that normally you all do for AI, which is AMX. AMX, I pointed out in the bottom, it's called AMX Advanced Matrix Extension, which is basically catering to the AI story, right? And now, I think today we are focused mostly on the networking and 5G. So if you look at it, there, we have a QAT engine is already there, which I think Sideload will go deep dive onto what QAT means. How does we do all the acceleration, all the crypto acceleration, all the stuff and all. So you can see for yourself, like, we have robust use cases that we support across these 5 categories. And then also security. I know Aziz touched upon some security as well. No matter what you do, no matter what application you deploy on a VM, you have the underneath, if you see the confidential computing, the bottom. On the left side, you see SGX. On the right side, you see TDX. SGX is nothing but software got extension. It actually does it does the application level protection. Once you have the application with the little code changes to take advantage of SGX, you're getting all your VMs, or you're getting all the application which is running on the VMs completely protected. TDX on the other end, like you don't have to do any code changes on the applications. You just have the application deployed as it is on a VM, and your entire enclave is protected. We call it TEE, Trusted Execution Environment. So you get that extra level of protection. So this is going to be available. We mark it in orange because it's going to be available somewhere on vSphere 9.0 timeframe. So look for that. So you're getting that QAT engine, which will have all those the offloading capability with encryption, and then with all those confidential computing with SGX and TDX, you're getting best of the both worlds. So with that, I'm going to pass it on to Saido to give more deep dive on the QAT.
Thank you, Kannan. Yeah, when we talk about networking and networking security and modern applications, and most of the CPU intensive tasks are cryptographic operations, especially where secure communication, data transmission, authentication, identity management, and all these operations are involved. And typically these use cases or scenarios uses protocols like IPsec, TLS, and SSL. And if you take any typical server environment in the cloud or data center or a private cloud, without hardware accelerations, normally cryptographic operations consumes up to 50% of CPU cycles. And obviously, of course, it depends on number of secure connections and volume of data. To address this, Intel introduced the Intel QuickAssist technology to offload all the cryptographic operations to dedicated hardware, and freeing up the CPU cycles to perform application-specific tasks, so that it improves overall system efficiency and performance. And so what is Intel QAT, Intel or QuickAssist technology? Intel QuickAssist technology is a hardware accelerator and designed to accelerate symmetric encryption, authentication, systematic asymmetric encryption, and digital signatures, and data compression and decompression. These are the key operations which consumes most of the CPU cycles, and Intel QAT hardware offloads all these to dedicated accelerators so that CPU cycles are freed up to perform application-specific tasks, so that overall system efficiency and performance is getting improved. Next slide. And so how it is available today. So earlier, around 2008 onwards, we started QAT delivery. And initially, most of the generations we are having as a dedicated PCI-based PCI mountable card, PCI card, QAT card. From Xeon 4th gen onwards, we started integrated as part of the processor, and we started deliver as part of 4th gen onwards as part of the processor. And it normally from 4th gen and 5th gen, we support up to 4 instances of QAT. In case of XCC models, extreme core count models, we support 4 instances of QAT, and MCC models, medium core count models, we support up to 2 instances of QAT. And here maximum capabilities you can see on the right hand side for the compression up to 160 gigabits per second on XCC models, XCC SKUs, and MCC around 80 gig. And the crypto AEAD up to 400 gig, and MCC 200 gig. And other modes like CBC, we support its maximum capability is around 200 gig, and MCC 100 gig. And other most important and CPU intensive one is PKE connection setup. And so we support 100 kilo operations per second on MCC 150. Thank you. And to summarize, overall value prop, QAT value prop for networking and storage and cloud deployments. First is performance. Intel QAT help to get best-in-class performance for the networking workloads and networking deployment scenarios by offloading the key crypto operations to hardware, QAT hardware. And so that it will free up the CPU cycles for the applications, and gives best-in-class performance for entire deployment. And scalability in XCC models and even in MCC models, we support 1 to 2 or 1 to 4 QAT instances, so that your application product line performance can scale up to whatever accelerations you need. So obviously, as mentioned, as shown in the previous cycle, it can go up to 200 gig or 400 gig, depends on the operation. And efficiency, normally dedicated hardware like QAT performs better than general purpose CPUs. So it leads to faster processing times and reduced power consumption. So internal, it brings efficiency to all your deployments, especially on the data center and the cloud environments where energy efficiency is a priority. Thank you.
Thanks. Thanks, Kannan and Saidlu. So I'll a little bit go further on how we are utilizing this capability. As you have all understood, what are the challenges which are needed with respect to scale, how Intel is exposing this QuickAssist technology in their CPU starting from Sapphire Rapids 4th gen, which they launched in 2022. How is Avi utilizing this, right? So Avi, as you understand, when we get deployed in most of the VMware environments, it's a VM form factor, right? So the VM runs on the ESXi host, right? And the ESXi host has those Intel chipsets on the server, right? So now if these chipsets have the QAT device inbuilt into them on the die, starting from 4th gen Sapphire Rapids, which was launched in 2022 onwards. And these are some of the CPU SKUs which have those capabilities, right? So what happens at the ESXi layer is the device gets exposed as a PCIe device, and the physical function PF is what we utilize on the ESXi. Each PF, as Kannan mentioned, has all those performance capabilities. So if you have one QAT device per chipset, and generally in a server, you have two chipsets, you will get two QAT PFs, which can be utilized by the load balancing VM for doing any of the layer 7 or layer 4 SSL offload. So what happens during SSL handshake, right? There is certificates which get exchanged and it has to be validated. And a lot of crypto functions need to happen as part of symmetric and asymmetric handshakes, which Saidlu had mentioned. And all those get offloaded to this QAT device, right? So this is what we are trying to do as part of our integration. The technology-wise, the VM registered the virtual function on the PF, and each PF can handle up to 16 VFs. And that means that we can have 16 VMs using one single PF, or you can give multiple VFs. I'll explain about how we are giving those configuration options to our users and utilize the capabilities of those PF devices and the QAT capability fully. So effectively, in summary, the QAT devices, which is inbuilt into the CPU chipsets, gets exposed as a physical function on ESXi layer, and the virtual function is what gets consumed on the service engine level. And whenever SSL operations are required to be done, those get offloaded to this device, and we get a callback and we process the packets much faster. So earlier, instead of doing it at a processor in a symmetric manner, now it happens in an async manner. We get a callback, and that's how we are able to improve the performance, right? But one quick note, not all processor sets have the QAT device by default. So please check out the product specification link for the processors which you need to choose to get the hardware QAT functionality. This QAT, as Saidlu mentioned, has been there for quite some time, since 2000s, and there are different generations of it. This is called as QAT 2.0 and gets exposed in hardware in these processors. The older versions of 1.5 and 1.0, 1.7 were available in the pluggable PCI device. But we are right now focusing on the inbuilt CPU so that user doesn't have to do any other configurations in their servers. They just buy their servers and deploy Avi, and they can utilize the hardware QAT functionality, right? So now the proof of the pudding, how is it improving, right? As you all know, RSA 2K is one of the most compute-intensive cryptographic functions for the SSL handshake. If you see what we have, the published numbers in orange, these are our current numbers published on our website. You can, if you go to Avi performance datasheet, you will see that with one vCPU allocated to the service engine, we are able to do around 950 SSL transactions per second if the RSA, if the certificate is used as RSA 2K. Whereas with Intel QAT with hardware offload, we are able to almost go 6x performance benefit. We are able to get 6,200, and in some cases we got more than that. And without the hardware capability, using just the software capability, we are able to see the 2x performance benefit. One quick note, this current published numbers is on the 2nd gen Xeon processors, whereas what we are comparing on the current QAT is with Gen 4, the Sapphire Rapids. So this effectively helps customers to do better cost to performance effectiveness, or even kind of compare with hardware appliances, right? People generally, when they want to look at performance, they think that a custom built hardware solves the problem, but we are able to achieve this much better results with generally available generic CPUs, which have these capabilities inbuilt. So let me quickly show you a demo of how this QAT looks like and how we are getting this performance benefits. So I'll share my demos environment in a bit. Just give me 1 minute. Okay, so here we are. This is a VMware environment where we have our service engines deployed, and as well as this is our controller UI. This is the Avi controller. When you log in, this is the virtual services view. So what I'm going to show you is basically I have a software QAT VIP. So I have a virtual service which is running on 100.99.131. And this is hosting SSL port. This is listening on port 443. And if you quickly look at the topology, this is right now deployed on one service engine VM, which is 10.2.11.172.177. Whereas on the backend server pool, we are load balancing to the 4 servers, 9.951, 52, 53, 54, listening on port 80. So front end is doing SSL, backend is pure text, or you can do SSL on the backend as well. But in this demo, I'm going to show this quickly, right? So we have software enabled web. We have QAT enabled in hardware, which is on listening on port on VIP IP 9.157. And then I have a scale out scenario because I mentioned Avi works in a elastic scale out model because we are software defined. We can have the same web run on multiple service engines. It's not like legacy load balancers, which can work in active standby only. The same web can be handled, the traffic for the same web can be handled by multiple data path service engine VMs, right? And we are going to showcase, so if I quickly show you the topology view, I have two service engines, 162 and 165. And this is again also load balancing the same backend 4 servers, right? And to show where are these in the vCenter, these are those VMs. This is the scale out SCVMs, and I have used one vCPU scale out. So I am effectively using 2 vCPUs across 2 VMs. And I have another SC with 2 vCPUs, right? And another service engine with 4 vCPUs to show you how performance changes with each of the form factor. And quickly to kind of show how is the QAT device, the VF, which I mentioned is mapped, is mapped on this VM. So if you come to the devices, this gets exposed as I mentioned, PCI device. So we are utilizing the VF of the physical device, the QAT device under which is mapped on the host. So where is this VM running? To kind of again show you that this is running on the host. This one, again, thanks to Kanan and Saidlu, they provided these servers for us to do the testing. So these are the servers provided by Intel team, and we are able to validate and test in our environment with these servers. So this is a 6428 processor. It's 64 logical processors, 32 cores, and hyper-threaded. If you see the QAT devices, which are, so each processor has 2 QAT devices. So effectively, there are 2 processors on these servers. So that's how we have 4 PFs. Right. And the good part in the ESXi integration is that you can look at the performance of each of these devices. So we can go to telemetry and you can see what is the latency on this device, how is the traffic transactions it is handling, and all those details nicely provided in the ESXi host managed devices under the Intel Device Manager, right? So this is on the device or the QAT device. And now let's come back to on the service engines, the data path, how they are utilizing, and how we are trying to get the traffic onto this, right? So I'll start with the QAT, hardware QAT enabled device. So this is running on one SCVM. So let me show you, this is that 156. And I mentioned this is 2 vCPU, right? So let me send the traffic on this, the VIP IP, let me double confirm. So the VIP IP is 157. So I'm running a WRK to send a lot of burst traffic. I have the client on from which I'm sending the traffic is a 32 core VM. And I'm just bombarding 30 threads with 700 connections. And it just does, if I show you the CPU view of this server, right? You can see all 32 cores are firing all these connections. And if I come back to our Avi UI, and let's see how it's handling the connections. In a bit, it will take some time to show it up in our UI. I was doing some test in the morning to make sure the things will be working. So this is, right now the traffic is being handled by a 2-core SCVM, right? Just give a couple of minutes, and we'll see how what's the throughput we are getting and what's the SSL performance we are getting. Let me see if we... Right. So if you see, it's handling 12,000 requests per second. This is two-core service engine, right? Whereas, as I mentioned earlier, published numbers, we used to do around 1,800 or 1,200 on 2-core, or 2,900 something. And now we are able to do around 12,000 requests, which is SSL transactions. And just to show you the log of that packet, this is the transaction which is getting handled by the service engine, right? The SSL transaction coming on the web. And it is handling 12,000 requests or transactions per second. So what I will do quickly is I'll move this to a 4-core service engine. I can so if you are a application owner and you want to migrate this web to a 4-core, right? And just to again double confirm, the 4-core is 157 IP. So I'll move to 157, migrate. It'll take a couple of seconds for it to migrate the traffic to the new VM. So let's suppose you wanted to handle more than 12,000, right? You want to handle 20,000 requests per second, right? All you have to do in Avi is just to click on migrate, and it will go to it is scaling it to the new service engine, which 157 became primary, and it will scale out from 156. Again, just click of a button. We also provide these capabilities as auto scale out, and based on the traffic patterns, automatically we can scale out to new service engine to handle this any increase in the load of traffic. So let's just do a refresh. Right, you can see the bump. It's from 12,000, it moved up to 22,000, right? So we had a 2-core service engine. Now we are using a 4-core. What we mean by 4-core is 4 vCPU, which is allocated to the service engine. Generally, if you have some questions, how do you do that? Is basically these are the CPUs which you allocate to the VM, right? And that's what we have done. But just by allocating more CPUs, we are able to drive more performance, almost the double, right? It scales linearly very nicely as well. Now, somebody might say that, hey, this requires a bigger service engine, right? What we can do is the scale out method. Instead of doing that, I can use a service engine. Here, you can see I don't have any requests right now. It is right now scaled to 2 service engines, and each service engine is 1 core vCPU. So in total, it is using 2 vCPUs. And if you see how we are handling that performance, I'll stop the traffic on this. And the VIP IP is 156 on this. So I need to just go and change the IP to 156. Right. Okay. There is some route that an issue. It is 10.1. I need to change 2 octets. So this shows that I'm doing actual demo, not a mock or something. So yeah, there you go. Right. So I am bombarding again traffic on this whip. And if you see, it started handling 13,000 requests per second. Effectively, it is scaled out to 2 service engines. I can scale out to more and more service engines as my demand has. And this is kind of horizontal scale. You're not vertically scaling, meaning you're not giving more CPUs to one service engine VM. You are able to create more service engine VMs, and the traffic is getting handled by them in a scaled out manner. So this is very powerful for a lot of customers, because let's suppose you have a Black Friday kind of sale kind of event where your application needs to burst and handle the traffic. You can scale out to 8 service engines at that time. But if you don't have a need, and it is like someday like today where you don't have much traffic, you can scale into 1 or 2 service engines and you can handle the traffic. So Avi provides this flexibility and scalability, which again, on the CPU level, what Intel is providing, how many QAT devices you want, the same thing we are kind of trying to expose it at a load balancing level, right? So that's with the demo. Let's get back to the presentation. So you can say, hey, we saw this, but how do we configure and use this functionalities? Some of those I showed you the steps, but effectively, you need to prepare the ESXi host, which means that you need to install the QAT driver on that host. And we work with SRIOV mode. It gives multiple options of how you can put the PCI device to be exposed at the host and the VM level. So we use the SRIOV mode, single root IO virtualization mode. And then you need to deploy the SC OVA. Today, this is through the controller, you need to deploy the OVA. We are in the roadmap, we are trying to make this automatically deployable service engines. And in the vCenter, as I was mentioning, you need to map the PF and VF to the device as a PCI device. That is the configuration you need to do. And on the Avi controller, on the service engine group, you need to enable QAT flag. And that's it. With these 4 steps, you will be able to fully utilize the QAT capabilities, which we can have at the load balancing service engine level. So quick few points. The minimum ESXi version required is 8. And the QAT hardware capability to be used is hardware version 2, which means the drivers which we test and we partnered with Intel with is the 2.5.5 of QAT 2.0 version. And on Avi side, the minimum version required is 31.1, right? And on the CPUs, as it was mentioned, it started from Sapphire Rapids. The later, there is a 5th gen, which is Emerald Rapids. And now we have Granite Rapids, the 6th gen, which was launched last year in September. So with those, you will be able to utilize these capabilities. So what is the summary and call to action? Avi with Intel QAT's capabilities addresses the security, scale, and performance challenges of our modern applications. And our elastic architecture and automation provides comprehensive load balancing and application delivery and application security services seamlessly to the private clouds. So you can look at the configuration guide, what we have in this link once you get the slides or the post the webinar ends. You can join other webinars. What we have free workshops, and you can also schedule some demos if you want these things to try it out in your environment. You can schedule some demos. Our teams will reach out to you and work with you closely to get it successful at your point. And also, having seen this, if you are today using any legacy load balancers, may it be FI or NetScaler or any other load balancers, you can migrate or move to Avi using Avi conversion tool. This is a GUI-based tool, very simple tool. You can just input your old legacy load balancer configurations, and it will give you the equivalent Avi configurations, which will make the migration a lot more easier. Instead of months, you can do it in weeks. And we have kind of put out some of the information and readouts on what are the problems with the existing load balancers, with iRules, with the upgrades, and the deploying of the VIPs taking weeks, months. We can do it in minutes. So we have some of those covered. So I'll then move to Q&A. Anything, Saidlu, Kannan, you want to add before we open up to Q&A?
No, I think you did a good. I mean, I like the way it flowed so far, and whoever wants to really experience this technology, the lab you showed, is pretty self-explanatory, and I would highly encourage, if you have access to it, just go test it out. You don't have to believe what we are saying about the performance unless you have a hands-on to it. Then you will have more confidence. So that's all I want to say here. But I thoroughly enjoyed this session for sure.
There was a few questions. Go ahead, Saidlu.
Yeah, Ajit. So if needs further information, what are further information and what are the algorithms QAT is supporting today, future roadmap, and people can contact us. We can provide the details, and also which are the generation wise, which are the algorithms are supported on each generation. Already the links are available in the session slides.
Sure. Thanks, Saidlu. Yeah, that's really helpful. So there were a few questions. I'll go one by one. There was one question on, do we need dedicated NIC for SRIOV to activate QAT? The answer is no. We don't have to do pinning of underlying physical VM NICs of the host uplinks to the VM. We use the standard SRIOV mode, so you don't have to do any pinning of the uplinks. Does the QAT also do a scale of vCPU on the file as well? Alan, can you clarify what do you mean by on the file? You mean encryption of the files, or the transport mechanism, or on the fly? Oh, okay, yeah. So yes, QAT supports on the fly. As I mentioned, the auto scale. We do auto scale of our service engines on the fly. But if you are explicitly asking about vCPUs, so the way what you can do is you will need to do a restart from the VM capabilities. Let's suppose you have a 2-core VM, you want to make it to 4-core VM on the fly. That requires a restart on the vSphere side itself. The VM, you need to kind of stop, change the config from 2 to 4 CPUs, and then start the VM again, right? But the way you can deal with it at Avi level is that you create the VM with, let's suppose, 6 CPUs, 6 vCPUs. In Avi service engine group properties, we give you the capability that, hey, use only 2 cores for doing the vertical scaling of vCPUs. So when the service engine gets deployed, when your applications, virtual services are getting deployed, it uses only 2 vCPUs. Now on runtime, you can change that from 2 to 4, because already that underlying SCVM has 6. You can change it to 4 to be utilized by the Avi to place the service engines and handle the traffic. So effectively, you create the VM first with a little bit bigger capacity of vCPUs, and Avi will have a way to kind of use only a portion of those CPUs, right? We can start with 2, 4. Generally, we do a multiple of 2. You can do odd numbers also. When you're doing dedicated dispatcher, you can do odd numbers as well. So I hope that gets answered. There was one new question from Rama. Is it okay to combine QAT and non-QAT to a specific application traffic? Very good question. So in the SE group today, you place the virtual service in one SE group. So in one SE group, we generally, right now, we are limiting that it should be uniform capabilities, meaning all service engines in that SE group either have QAT capability or don't have QAT capability. What you can do is you can create the virtual service on a service engine which doesn't have QAT capability. And runtime, you can move the VS to a new service engine. There'll be a little bit glitch of traffic because the VIPs have to be kind of mapped to the new data path on a new service engine group, but it will be minimalistic kind of a switch for your virtual service. But if you're saying same virtual service, I want to handle both QAT service engine and non-QAT, that we have not done. We didn't see it as a use case. We can follow up with you, Rama, on it. If you have a specific use case, we'll try to see if we can do that in a roadmap.
Ajit, related to NIC for SROV and QAT, the answer is QAT and NIC both are independent devices. There is no connection, so NIC separately works. Yes. And for the QAT, the configurations are completely different. The NIC card doesn't come into picture when you are using QAT for crypto.
Yes, thank you, Cyril. Yeah. So just to again reiterate, we do utilize some of the NIC capabilities like RSS and TSO, which is like to receive side scaling. We can do more queues to enhance the performance, or if you have the NICs with more queues, like for example, Intel, some of the E100 NICs, they can support more than 1,000 queues. So we'll be able to do a lot more performance on such such NICs. And those configurations are separate from the QAT, what we discussed today. So QAT capability is part of the CPU, and the configuration or the offload of the packet when it hits the NIC, when it comes to our dispatcher on the service engine load data path, gets offloaded to the QAT device as a separate device. It's not in the path of the network NIC card IO, right? So, okay, I think that same question, SRIOV on the SCVM level. Yes, we did that at SCVM level. But it doesn't require pinning of the uplink is what I'm trying to explain on it. We need, and also that is for QAT. SRIOV again is for the QAT device, not QAT, NIC device. Again, I think there is some confusion where there is a SRIOV capability on the NIC, and this SRIOV is on the PCIe device of the QAT. So QAT gets exposed as a PCIe device, and we are exposing that as SRIOV, not the underlying pinning uplink. Uplink has nothing to do with it. It can run in the shared mode and however it is running. I hope that answers the question. Okay. Any other questions? We have a couple of minutes more. We'll hang around if there are any questions. Thanks a lot for joining today's session. And please feel free to, as Saidlu said, reach out to us. We can provide a lot more details on the capabilities, the ways to kind of solve the performance and scale issues on your side.
All right. Thank you all.
Thank you all.
Thank you. Thanks, Helen.